Happy Monday, everyone. This is Patrick Hess, your Planetarium specialist, tuning in for another Monday afternoon deep dive live stream. Thanks for joining us, everyone. If you're showing up here for the first time, welcome. We are going to take a 45-ish minute long deep dive into an astronomy topic, as we've been doing for the past few months now. And if you're joining us, once again, welcome back. Thank you so much for continuing to support the Planetarium and all that we're doing online. A couple quick little housekeeping notes. Just as a reminder, Union Station and the Arvin Gottlieb Planetarium are now open to the public. You can buy tickets online, but please keep in mind that we do have limited seating because we are enforcing safety, cleanliness, and social distancing policies. We strongly encourage you to buy tickets online in advance, which you can find our schedule posted there as well. We're going to be bringing in we're going to be changing our schedule up starting this Friday, featuring the classic Dinosaurs at Dusk, one of our fan favorites, to coincide with the opening of the new exhibition at Union Station, Dinosaurs Road Trip. So be sure to check that out. Head over to unionstation.org for all the information about everything going on at Union Station. And I hopefully will see you under the stars at the Planetarium. For now, though, we are going to be under our virtual sky here in our live streaming universe, I suppose. Today's deep dive is going to be all about Jupiter. Now, we've covered Jupiter actually way back, all the way in April, during our very first Wednesday deep dive, back when they were on Wednesdays, when we went through a solar system tour. But in case you haven't learned by now, I'm a bit long-winded, and during that solar system tour, I spent way too much time on the inner planets and didn't have a ton of time to talk about the outer planets. So I figured now that we have kind of covered a lot of other different topics, it would be great to kind of loop back around and dive a little bit more into some of those outer planets, because there's a lot of cool and interesting stuff to talk about. And today we are going to focus on Jupiter. Another quick note, if you wanted to watch any of our previous live streams, our star tours, our deep dives, or even the Fan Fridays where we answered all your questions, you can find all of those on our Facebook pages, or you can go to YouTube and check out the Arvin Gottlieb Planetarium's YouTube channel, where I've gone ahead and curated playlists of all of our live stream content so far. I'll upload this one there as well, so it's easy to find and you can watch them all in succession. If you want to have a marathon to watch all of our deep dives, you can do that, and you can experience in real time or in fast-forwarded time the progression of my quarantine haircut as well as beard length. So enjoy that for sure. But I'm already getting long-winded, and we have a lot of stuff to cover, so we are going to dive in to our topic for today, which is going to be Jupiter, the king of the planets. So Jupiter is by far the biggest planet in our solar system. It is bigger than all 7 other planets combined by 2.5 times, and you could fit 1,000 Earths inside of Jupiter. And we are going to be using a variety of different software pieces today. We are going to start out over in Universe Sandbox, where there are some really great simulations all about all about the sizes of our solar system. So let's go ahead and bop on over here. So this is showing us a simulated view, or a simulation of the sizes of the planets in our solar system. So now this is not how the solar system is actually laid out, of course. Planets are not this close together, but this gives you a really nice picture of the relative sizes in our solar system. So you can see Jupiter is quite a bit larger than all the other planets. Of course, these all pale in comparison to the size of the Sun, which we can lay out here right next to all of these other ones. So now you can see, compared to the Sun, our planets make up just a very tiny amount of the total mass of our solar system, including the Sun. Here's another kind of fun little simulation that's in Universe Sandbox. A lot of people don't realize that the Earth and the Moon are so far apart. Oops. Actually, that was the one we were looking at. The Earth and the Moon are so far apart that all the planets could fit between them in their orbital spot. That was what we were actually looking at here. So the Earth is right there, and the Moon is way over here on the edge. All the other planets actually fit between the Earth and the Moon. So kind of just another idea of just the scales going on in our solar system. So let's talk about Jupiter. Now, Jupiter is, like I said, the largest planet in our solar system. And Jupiter is very interesting. Jupiter we might think of as being a very, very distant point of light. You can actually see it tonight. It'll be rising in the early evening, soon after sunset over in the east. It'll be the brightest point of light, quickly followed about 15 minutes later by Saturn. Those two planets are very close together right now, and I'd encourage you to check out one of our live streams or come see one of our star tours where we talk about the very rare event that will be happening with Jupiter and Saturn. But Jupiter will be visible in the early evening, but it'll just look like a tiny little speck of light. And you might think that Jupiter is so far away that it couldn't possibly influence anything here on Earth. But that is not true, because Jupiter has had a profound influence, and still does today, on Earth and life on Earth. So early on in Jupiter's life, early on in the life of the solar system, Jupiter did something kind of crazy. It went on a bit of a rampage, storming through our solar system and affecting how our solar system was formed. So Jupiter is sometimes nicknamed the king of the planets, but we could also call it the godfather of the planets, because Jupiter has been kind of the architect of our solar system. And we're going to kind of walk through how that is, and or why that is. So we can actually see evidence of Jupiter's effect on Earth in a few interesting places. This right here is a meteor crater, the Barringer meteor crater, that is in Arizona, and this is just looking at it through Google Earth. There we go. This is a gigantic meteor crater that you can visit yourself if you'd like. There is an observatory and museum there. Again, this is in Arizona. And this meteor crater is about 50,000 years old. The meteorite that caused it was about 50 meters across and was traveling at about 15 kilometers per second. So it took about 7 seconds to get from the edge of the atmosphere all the way down to the ground. And the energy that it released when it impacted was equivalent to about 10 megatons of TNT, or a really large nuclear bomb. This meteorite came from the Asteroid Belt, and it most likely came to us because it was deflected by Jupiter's gravitational influence. So Jupiter, let's look at Jupiter. Actually, let's go over to Space Engine here, and we've got Jupiter loaded up. Jupiter is a gas giant planet. It's mostly composed of hydrogen and helium. That's the same stuff that our sun is made out of. In fact, when the solar system was forming, there were various balls of gas coalescing due to gravity, and Jupiter, Saturn, and the sun were 3 of those balls of gas. Now, only only the sun got big enough to ignite stellar fusion and become a star, and Jupiter and Saturn never quite got big enough to get to that point. But they have sort of similar paths, and they started out the same way. So, because Jupiter is the second largest object in the solar system, it exerts an influence on our solar system second only to the sun. And now this influence can cause more than just the occasional crater impact, which we will see throughout our show today. And this influence can really change the course of the formation of entire planets. So Jupiter, like I said, was the first world in our solar system. It formed right alongside the sun. And it was created very early on in our solar system, before the inner planets were formed, before Saturn was formed. And because it was born so early, it swept up a lot of the material that was left over from the formation of the sun. And so Jupiter contains a large quantity. If we subtract the sun, Jupiter contains a large amount of the mass in our solar system. So our solar system, let's talk about it, because it's pretty nice. It's kind of oddly satisfying, if you'll... I think you might agree with me, because, well, there are 8 planets, as we have very controversially discussed. Again, we're not going to debate that right now. But they are divided quite nicely. There are 4 inner planets: Mercury, Venus, Earth, and Mars. There is a belt of asteroids sort of laid out between Mars and Jupiter. And then the outer planets are Jupiter, Saturn, Uranus, and Neptune. All the inner planets are small rocky bodies. All the outer planets are gas planets, gas giants or ice gas giants like Neptune and Uranus. Now, for a long time, scientists thought that this was just sort of the natural order of planetary systems. That was until the past few decades, when we started to detect exoplanets. And exoplanets and planetary systems outside of our own often do not follow this arrangement. In fact, most solar systems that we have found, most planetary systems that we've found, do not have small rocky planets on the inside. Most of them have what we call super Earths. So a super Earth is similar Earth. It's a rocky planet with an atmosphere, but it's vastly larger than a typical, well, than how we typically think of the Earth. Much larger, much more massive, and a lot of these worlds we've found have been covered in thick and toxic atmospheres, which likely make them inhospitable. So these super Earths just have poisonous atmospheres, massive gravitational fields because of their larger mass. So we don't think that they likely have life, at least life like we know it here on Earth. So the question then is, why is our solar system like that? Why is our solar system special? And remember, folks, as we're going through this, if you have any questions or comments or just want to say hi, feel free to throw them up in the comment section because I love hearing you guys chat, and it makes me feel like I have more of an audience. I'm a performer. I like performing in front of a group. So feel free to say hi, and if you have any questions, we will keep track of that. But let's return to our discussion about the solar system. Why is the solar system like this? Now, to answer this question, scientists and astronomers and planetary scientists and people in NASA and other organizations involved in space travel around the world have sent spacecraft to every planet in our solar system, as well as many of the moons and other orbiting bodies. And when we've done that over the past half a century, we have discovered some really strange anomalies in our solar system. For example, Venus, which is currently the hottest planet in our solar system, temperatures reaching over 900 degrees with a dense and poisonous atmosphere, we have discovered that Venus used to have a lot more water on its surface, liquid water, than you would expect a planet that close to the sun to have. On the other side of the Earth, Mars is extremely small. It's only about 10% of the mass of Venus and Earth. So it's a mystery of why Mars is so drastically different. And then there's the Asteroid Belt, which is full of hundreds of thousands of small rocky bodies, as well as some larger objects that we consider to be failed worlds whose growth was mysteriously cut short. Something catastrophic must have happened to stop the formation of these worlds sort of in that graveyard of the asteroid belt. So let's rewind time back to about 4.5 billion years when the sun first ignited and Jupiter was just forming. Well, during the very early days of our solar system, Jupiter's orbit was drastically changing. It was constantly moving around as it gained mass. And we know this because of the trail of destruction that it left in its wake. So as Jupiter was, let's full screen here. So again, this is at the dawn of our solar system when the sun had just ignited stellar fusion, and Jupiter had just formed its mass and it was on the move. It was starting to travel through the gas and debris in our solar system. As it moved around the sun, it cleared a path. It cleared this trail as it gobbled up all these other objects around it. As the sun cleared this path, it caused some of the objects closer to the sun, outside of its reach, to fall inwards towards the sun. And due to an effect in physics called accretion, Jupiter was actually pulled along with them, sort of like a riptide, and Jupiter started traveling towards the inner solar system. The asteroid belt is the main evidence of this. The asteroid belt contains a very little mass, about 4% of the mass of our moon. The average distance between any two asteroids is about 8 times the distance between the Earth and the moon. So any science fiction or any space movie you've seen of the asteroid belt where these asteroids are close together and crashing into one another, that is fiction. Asteroids are not that close, very, very distant. You wouldn't even be able to see another one if you were on one of the asteroids. And there was a mission to explore the asteroid belt. It was called the Dawn mission. It took place in the early 2000s. And this spacecraft explored many of the bodies in our asteroid belt, but most notably two of the largest objects, let's go over space engine, the asteroid Vesta and the dwarf planet Ceres. Vesta, I think, is my favorite asteroid, mostly because it reminds me sort of a potato. It's sort of got this long shape. Some interesting, like, sort of cracks on its surface and striations around the central equator there. But more interestingly was a Ceres, which is the largest object in the asteroid belt. It contains about 1/3 of the mass of the asteroid belt, in fact. Now, Dawn, the spacecraft, took close-up photos of Ceres. It reached Ceres around 2015 when it got some of this imagery. And in these photos, as we can see here in Space Engine, some of the photos revealed these very bright, highly reflective patches of surface. Now, there were some conspiracy theories about alien cities or something like that, but scientists use spectral analysis to analyze what this material is made of without even having to land on Ceres, and it discovered that these were actually deposits of salt that likely came from water on Ceres. So these salt deposits, which actually cover the entire dwarf planet here, suggest that there is a large amount of ice water below the crust. And extrapolating what we've known and found out about Ceres, we have a picture of its interior, and its interior is very, very different than all the other objects in the asteroid belt. Also, it's very round. You know, all the other asteroids are smaller rocky bodies that aren't quite shaped like this. So all of this information kind of combined for astronomers and planetary scientists to make the assumption and the hypothesis that Ceres was on its way to becoming a planet. That was until Jupiter, as I said, was passing through that region of space where the asteroid belt was and gobbled up most of the mass in the asteroid belt, which stunted Ceres development, and it never quite got big enough to become a planet. So if that hadn't happened, if Jupiter hadn't been there, then Ceres may be a planet just as big as the Earth. So we can see the effect of Jupiter's massive gravitational field perhaps best in one of its moons, Io. So let's go on over to Io. Io is one of Jupiter's that's not Io. That's an asteroid called Io. That's funny. We want to go to the moon Io. There it is. This is one of my favorite moons, orbiting very, very close to Jupiter. Io is the most volcanic world in our solar system. It's covered in hundreds of active volcanoes, and yeah, there we go. And there are oceans of molten lava covering its surface, much larger than any other patch of lava in our solar system. The largest volcano is called Loki. It's 125 miles in diameter and about 1 million times larger than any lava lake on Earth. And it often exhibits plumes of lava rising 200 miles above the surface of that moon, which we can see here in imagery captured by a spacecraft that passed by Jupiter. I'm not sure which spacecraft exactly, but again, that is Io, and there is the just the plume of lava erupting there. So far up, we can see it from space. Now, Io is this way because of its proximity to Jupiter. Now, let's talk about the volcanism on Earth. Why does Earth have volcanoes? Well, most of the volcanoes on Earth are due to residual energy that is stored below the Earth's surface, left over from the Earth's formation. So, heat radiating out, as well as plate tectonics, moving the crust of the Earth around. But Io is different. Io is much smaller than the Earth, so it does not hold as much residual energy from its formation. Its volcanism is due to something called tidal heating. So Io is one of the closest moons to Jupiter, but the next moon out is Europa, another Galilean moon, and like I said, we'll talk about the Galilean moons a little bit later. But these moons orbit in a resonance. So Io is orbiting around really rapidly, but Europa is a bit farther out and orbiting much more slowly. But it's actually orbiting in an exact pattern. For every one orbit that Io does, for every one orbit that Europa does, Io orbits 2 times. So half of the time, half of Io's orbits, it actually will pass by Europa. And as they pass by each other, they affect each other's gravity because they are so close and because they are relatively massive moons. This orbital resonance gives Io sort of a gravitational push, which briefly stretches its orbit. Normally it's a circular orbit, but when Europa passes it, it becomes slightly elliptical, and then eventually it compresses back down. And this, in turn, will affect the actual composition of Io, and the mass of the moon itself will pull, stretch, and compress, and that friction causes the volcanoes on Io. We call this tidal heating. And so Jupiter has a profound impact on its own moons, and it is causing its own moon Io to never quite cool down, just being constantly covered and plagued with intense volcanic activity. Now, we don't feel Jupiter's influence today as directly as Io, but in the early days of our solar system, Jupiter was on a trajectory where it could have definitely influenced us. After passing through the asteroid belt, it entered the inner solar system. Now, back then, the inner planets were not forming, so Jupiter was getting ready to gobble up all the material that was eventually going to become the Earth, and that would have been pretty bad for us, of course. Now, that's also why we think Mars is relatively small, because Jupiter started to gobble up the material that eventually was going to become Mars. But before it had a chance to gobble up everything inside in the inner solar system and stop the formation of the Earth, something stopped it. Another gas giant planet, Saturn. Remember how I said Saturn formed a little bit after Jupiter? Well, by the time Saturn formed, it was also starting to move inwards into the inner solar system, but it was moving a lot more rapidly due to a number of gravitational effects, and this created a resonance with Jupiter, kind of like the moons Io and Europa. And due to a bunch of other complicated gravitational interactions, which we don't have enough time or math to get into here, a weird thing happened, and basically both Jupiter and Saturn pulled each other back out. So as these two planets were heading to the inner solar system, one of them came around and their gravity kind of churned up a little bit, and they eventually got pulled back out. So that allowed the Earth to form, and that kept Jupiter from gobbling up all the mass in our solar system. Now, Jupiter did leave us with one parting gift on its way out. As it passed back through the asteroid belt out to the outer solar system, it kicked up a bunch of asteroids in the asteroid belt and sent them hurtling towards the inner solar system. And now a lot of these asteroids are very icy bodies covered in water ice. And so a lot of scientists theorize that a lot of the water on Jupiter, a lot of the water on Earth is due to those asteroid impacts from Jupiter's passing of the asteroid belt. So now a lot of this seems like really complicated and contrived. You know, the Jupiter coming in and then getting pulled back out, and all these things interacting, and water coming to Earth and all that. But I will say that we have done a lot of, well, the scientists with more expensive computers than me, have done a lot of computer simulations to test out these theories, and this basically confirms that these interactions could likely create a planetary system like the Earth. And that is all due to Jupiter's mass, and Jupiter not becoming a star, because if Jupiter had gotten too big, it would have become a star, and that would have been a totally different story. So let's talk a little bit about the asteroid belt. I meant to talk about this earlier because Jupiter influences our solar system on an extremely grand scale today. These dots represent tracked asteroids that we know, so we can see the dates here passing by. So this is tracked data over the course of a few years, over a decade it looks like actually. And you can see here there are a number of asteroids that sort of orbit in this weird triangle shape. And then there are these sort of teal asteroids out here that are orbiting just in front of and behind Jupiter. These teal asteroids actually have a name. They're called Trojans, and they are sort of locked in this orbital resonance because of the massive gravity of the Sun and the slightly less but still very massive gravity of Jupiter. They are sort of locked in this perpetual trailing behind or riding in front of Jupiter's orbit, and then they interact with these pink asteroids that kind of get pulled in and out and sort of stay in this resonance. So a really, really cool interaction, and how Jupiter does impact us on a very, very large and profound scale. So right now, Jupiter has made it all back out to pass the asteroid belt, and by this point, Jupiter and Saturn's orbits have stabilized, and they won't be moving around anymore, so we don't have to worry about Jupiter coming for us again. But its current position does still give a huge influence on the asteroid belt, like I just showed you with that animation. Jupiter still affects the asteroid belt quite a bit, and Jupiter does occasionally dislodge asteroids from the belt, because of these complex interactions, and occasionally those asteroids will be sent inwards towards the solar system. The asteroid that likely caused the extinction of the dinosaurs, many scientists think that that asteroid likely came from the asteroid belt because of Jupiter. Now, a lot of scientists will also agree that without that extinction event, mammals may not have risen to the point that they are today, and humans may not have evolved. So another reason why we may owe our existence to Jupiter, that asteroid that wiped out the dinosaurs paved the way for us. Now let's just keep our fingers crossed that another asteroid doesn't come our way. Now, it also protects us, so it doesn't always just send asteroids careening towards us. It also protects us from objects coming from outside of the solar system, and we can see this, or we did see this, in the Schumacher-Levy 9 comet. Now, this is a comet that we were tracking for a number of decades, but in the I forgot to write down the exact date of this. Yes, it was July of 1994. So in July of 1992 through July of 1994, it interacted with Jupiter in a very extreme way. So starting in 1992, this comet, which was careening towards the inner solar system and could have been careening towards Earth, Jupiter, its massive gravity, captured this comet. First, it started to rip this comet apart, and then over the course of 2 years, ending in 1994, this comet actually crashed into the clouds of Jupiter. And astronomers were tracking this, and they were able to witness this in real time. Over the course of 6 days, these impacts scarred the lower hemisphere of Jupiter. This was the first time a comet impact was ever witnessed by humans. And some of these scars were larger than planet Earth. So this is a little animation, or it's a video really, of one of these impacts crashing into the clouds of Jupiter. So again, maybe Schumacher-Levy 9 wasn't going to impact the Earth, but over the course of billions of years, Jupiter has likely captured many objects like this, and these objects could have been dangerous to the development of life on Earth, and they would definitely be dangerous to the continuation of it today. Let's check in to our comments section, and looks like Deano is chiming in. Glad you're enjoying the graphics and slides. Yeah, I try to mix things up and have a lot of different imagery as well as all the software, and we do try to post links to where you can find this software yourself in the comment section, so if you'd like to see any of this imagery yourself. And yes, I agree, let's definitely keep Jupiter happy, because Jupiter is kind of like the solar system's bouncer. You know, it's stopping everybody at the entrance before they get to us. All right. So, again, the main point I've been trying to make here is just that when you look at Jupiter and you see that little tiny speck of light in our evening sky rising towards the east, we might think that that thing is very far away and couldn't have any influence on us, but really Jupiter does have a profound influence on our solar system. It has since the formation of our solar system, and it continues to today. So just another way that we are connected to the cosmos in a much stronger way, and a lot of people feel very disconnected when they look at the stars, but hopefully this will be one way you can feel a little more connected. So let's talk about Jupiter a little bit more. Now, Jupiter was one of the, well, we have seen Jupiter for thousands of years, because Jupiter is visible to the naked eye and usually one of the brightest points of light in the night sky. Cultures throughout history have seen Jupiter and considered it as a very important body in space. Now, before we knew a lot about the mechanics of our solar system and universe, Jupiter was often attributed to a god, often the king of the gods. Look to the Greeks and Romans. They saw Jupiter as representing Zeus, the king of the gods, or the Romans called him Jupiter. And then you'll find many other cultures referencing Jupiter as their king. Now, one of the first observations of Jupiter through a telescope was Galileo, that famous astronomer from a couple hundred years ago. And Galileo was also the namesake for the Galilean moons. Now, when Galileo looked at Jupiter through his telescope, he saw the bands of clouds on Jupiter. He even saw the Great Red Spot, which we'll talk about in a minute. But he also noticed a couple bright points of light sort of lined up next to Jupiter. And Galileo, being an inquisitive person and a scientist, decided that he would record these points of light over the course of a few nights. These are actual drawings from Galileo's notebooks. And as he recorded these points of light over the course of a few nights, he noticed that they appeared to be all staying in line with each other, but they also appeared to be kind of going back and forth, side to side, some of them more quickly than others. Now, the 4 moons that he saw through his telescope were Io, the one we saw already. He also saw the moon Ganymede, which is this one over here. It's a very large moon in our solar system. I believe it's the largest moon in our, Ganymede is the largest moon in our solar system right here, but it is a relatively dead and cold world. It saw the moon Callisto, or Galileo saw the moon Callisto, another rocky moon, a slightly different coloring due to some mineral deposits on its surface. And then, there's Jupiter in the background. He also saw Europa, which is a very unique moon. It is an icy moon. We'll talk about Europa in just a moment. Going back to Galileo's drawings. So as he was observing these points of light darting back and forth, this was one of the first bits of evidence that led him to his theory that the way that the European cultures at the time saw the universe, which was the sun and the stars going around the Earth, may have been wrong, because he saw these objects going around one of the heavenly bodies. And so, extrapolating that idea, he thought, well, if these moons go around Jupiter, then maybe Jupiter goes around something else. Maybe it goes around the sun. And this was kind of the first thing that led him to starting to think about the solar system in this way. So we talked about Io a lot. Let's talk about Europa, though. Europa is an icy world. It's covered in long cracks covering its surface here. And the missions to Jupiter that have studied it have taken close-up photographs of all the moons, and some of these spacecraft have done spectral analyses on the surface, which is why we know that the surface of Io is covered in water ice. Now, upon further investigation and further spectral analysis, as well as observing some of the cracks on Europa, as well as material emanating from those cracks, geysers specifically, we have learned that Europa is a water world. So Europa is close enough to Jupiter that it is tidally active, like Io, but not to that extreme of a degree. There's enough gravitational influence from Jupiter that Io's core is relatively warm and molten, and is able to hold a lot of residual energy. But then below the icy surface, at some places about a mile of ice, there is an ocean of liquid water. And because the core of Europa is warm, this ocean of water is likely warm water as well. So we've got this moon out in our solar system that has a giant ocean covering the entire planet below this surface layer of ice. And that is why Europa is near the top of many scientists' lists for places that we would like to explore in our solar system someday. NASA is working on missions to Europa, as well as other icy moons like Saturn's moon Enceladus. And hopefully we'll be able to send a mission there to land on the ice, perhaps drill through it, perhaps send a submarine below the ice to explore those watery depths. So hopefully sometime in our lifetime we'll be able to experience that mission. That would be quite incredible. Now let's get back over to Jupiter. Let's talk about the Great Red Spot, one of Jupiter's most famous features. Right now it appears to be hiding in the nighttime side, so we're going to fast forward time a little bit until it pops up. Now, this imagery that you're seeing here in Space Engine, and the imagery you'll often find in photos of Jupiter, as well as videos or even simulations like this, is pretty old. This footage was captured by the Voyager spacecraft that passed by Jupiter back in the 70s and 80s. Now this is pretty awesome footage. These spacecraft were able to capture video footage of the entire surface, and so we could stitch it together to sort of form this this full image of Jupiter, this full animation. But this is old imagery, and we have, you know, better photos of Jupiter, or more recent photos. And more recent photos of Jupiter have shown that the Great Red Spot has been shrinking. That's right, the Great Red Spot is not as big as it was in these iconic photos. In fact, it's about half the diameter that it is in this imagery. And so scientists think that this Great Red Spot might actually be disappearing within our lifetimes. Now, this is simply a gigantic hurricane that we think has been raging for about 300 years. So it makes sense that these hurricanes would change and disappear. In fact, there are other smaller hurricanes that have been developing nearby, so they may become new Great Red Spots. But that is just a reminder that Jupiter is a volatile world, that surface and clouds are constantly changing. I should mention, by the way, we don't know if Jupiter does have an actual surface. Right now, the Juno mission, the spacecraft that reached Jupiter recently, is one of its main mission objectives is to try to learn about the composition of Jupiter and try to figure out if there is a solid core below these clouds. We don't really know. There are some simulations that scientists have done to try to figure out the chemistry going on below the clouds of Jupiter, and if there could even be a stable solid core or even a ground to Jupiter. But the verdict's still out, so we won't really talk too much about that. One other detail about Jupiter that may show up in Space Engine here is that it actually has rings. Now, Saturn's rings are so bright and visible because they are made of water ice, which is very reflective. But Jupiter's rings are more dusty. Oh, there, we can actually see that. So if I angle the light just right, and I can actually increase the exposure here, we can see that Jupiter does have a very faint system of rings going around it. And again, these are mostly dusty, so they're not quite as reflective. But it does have a ring system similar to Saturn's ring system. This was likely formed when a moon was ripped apart by Jupiter's gravitational influence. But this moon that was ripped apart was a lot less massive and less icy, so its rings are not quite as visible. I'm going to backtrack a little bit because I realized there was one other simulation I wanted to talk about. I wanted to compare Jupiter's size to some other objects. Let's pull this up. Where is it? There we go. Put that a load. So there are a lot of different types of objects in our solar system. You know, I'm sorry I didn't bring this up earlier, but we have the Earth and Jupiter here. And now, Jupiter and the Earth were formed around the same time, but Jupiter didn't quite get big enough to ignite stellar fusion, and the Earth is a rocky body, so they are fundamentally different in their composition. But Jupiter fits into a category more similar to the Sun. Now, if Jupiter had gotten much bigger, it could have become a brown dwarf, where it wouldn't have ignited stellar fusion, but it would have enough mass that its mass and just the pressure of all that mass pushing inwards with the gravity would cause it to emanate a small amount of heat. We call these objects brown dwarfs. Again, they are not igniting nuclear fusion. They're not converting hydrogen into helium, but they are relatively luminous. They are emitting some light themselves. This is one of my coworker Jordan's favorite brown dwarfs, which is Gliese 229b. You'll have to ask her more details about that one. That is a dwarf planet found in an it's an exoplanet found around a distant star. And then we have the Sun. So if Jupiter had gotten big enough, there would have been enough force in the core to start fusing hydrogen into helium to start that nuclear reaction, and it would have been turned into the Sun. To give you a little bit more perspective on sizes of things in our universe, Sirius right here is the brightest star in the entire night sky, but it's actually not that much larger than the Sun. It is quite a bit hotter, though, and likely quite a bit younger than the Sun. And then the second brightest star in the sky is this one over here, which is called Arcturus. And you can actually see Arcturus if you look up at the night sky almost directly overhead. Soon after sunset, you'll find Arcturus. It's a bright red star. It's a red supergiant. And so These are some relative sizes. Arcturus is one of the largest stars that we know of. So even though Jupiter is the biggest planet in our solar system, it still pales in comparison to some of the larger objects out there. So the last thing I wanted to leave you with is I wanted to clue you into this really, really cool thing that NASA has put together, which I will find. Let's see, there it is. Okay, so Juno, like I said, is one of the most recent planetary missions, and it is still currently exploring Jupiter, and it is capturing some really amazing imagery. Here is some photos captured recently of the poles of Jupiter, and the poles of Jupiter are actually a lot bluer than we used to think. So that sort of orangish, whitish image of Jupiter that so many people grew up thinking of is not quite correct. Actually, Jupiter does have quite a bit of blue in it. So the Juno mission, you can learn all about it on its website at the Jet Propulsion Laboratory, which is the division of NASA in charge of maintaining these probes in space. And we can put a link in the comments to that, where you can download a program that you can put on your computer, which we can load up right here. This is called NASA's Eyes, and this has a bunch of different missions and a lot of great interactive experiences you can check out. And there is one all about the Juno mission. So we're going to load up the Juno mission visualization here, and I'll just show off a little bit, but this was something that you get to explore at home. And so we actually have a simulated view of Juno, the spacecraft, right here as it spins around. And if I click on Explore, we come across a lot of really awesome information. This is Juno's current location. And we can track its trajectory here. So here is the orbital trajectory of the Juno spacecraft. It's taking a very, very eccentric orbit where it's going very far away and looping in incredibly close. It's when it flies by Jupiter, it travels very, very close to the clouds of Jupiter, and it passes by Jupiter in about 2 hours. It zooms straight through there, and it travels so quickly that they have to send it way, way back out here so it can cool down a little bit. And so so this program is really awesome. It allows you to adjust the view here and animate the orbit over time, and it has even a this sort of timeline down here, so you can actually track Juno as it left Earth here. So we can zoom way, way out, and we can see Juno flying and being captured by Jupiter, and then we can actually watch its entire orbital path, and then even fast forward all the way to the end when when Juno will be purposefully deorbited into the clouds of Jupiter, just like Cassini, the spacecraft that orbited around Saturn. Juno is kind of like the next Cassini, only Juno is focusing on Jupiter. But there is a lot of awesome information here that lets you explore all sorts of things about the atmosphere, about its interior. It even does a cutaway. This is based on some current theories about Juno's interior, and you can read more about this. You can even see a little bit of detail about Jupiter's rings. So a lot of really great information. And again, this is a free program that NASA offers. I'd encourage you to download this and check it out and learn all about Jupiter for yourselves. We can even see Jupiter's magnetic field as well as its aurora. That's right, Jupiter has its own northern lights. So a lot of really great information and a lot of fun stuff to explore on your own. Again, we will post a link to this in the comments if you'd like to check it out. But that actually perfectly brings me to the end of my notes, which brings us to the end of our stream today. A couple last housekeeping things. Oh, one thing I didn't mention, Jupiter has 79 known moons. It, however, does not have the most moons in our solar system. That title now belongs to Saturn. Saturn has 82 known moons, thanks to 20 new moons getting confirmed about a year ago. So Jupiter used to have the most moons in our solar system, but now Saturn has the most confirmed. However, there are likely many more objects that we will continue to find as time goes on. Well, that was a lot of information about Jupiter, a lot about how Jupiter's formation and its influence over the course of the history of our solar system has impacted humans and the Earth in a very profound way. We've talked a lot about Jupiter's moons, diving in depth to a couple of Jupiter's Galilean moons, some of its most famous that you can see if you look at Jupiter through a pair of binoculars. You can even see the Galilean moons, just like Galileo saw them. We've looked at some awesome information that you can find for yourselves in a program that you can download from NASA. But this does finally bring us to the end of today's deep dive live stream. Thank you all for listening. Thank you all for tuning in. Thank you for continuing to support the Planetarium. Remember, we are open, and you can now support us directly by buying a ticket to the Planetarium, where you can come see me or Jordan or some of our other amazing educators give a live star tour. We also have great programs for kids. We have a show based on the kids' book series Magic Treehouse, where they take a mission to space. We have the fan favorite Big Bird's Adventure, One World, One Sky, where you can join Big Bird as well as some other familiar friends learning about the stars. That is a great show for our early learners. And we have right now a movie about Mars, and starting this Friday, a movie about dinosaurs that you can check out for yourselves. Remember to buy tickets in advance online. That is a great way to support me, to support these continued programs, and to support Union Station. And always think about buying a membership as well, because that gives you even deeper discounts to all of our programs. Now, I normally announce what our next stream topic is going to be, and I'm going to do that now. Next week, we will be diving into comets. We've talked a little bit about comets during a few of our deep dives, but we're going to do a whole stream all about comets, not just the science of comets, but we are going to talk a little bit about the history of humans' understanding of comets and the cultural implications comets have had, prophecies that they have foretold, their appearance in pop culture, and their depiction in art. So a lot of interesting stuff about comets, and we're going to dive all into that starting next Monday at 6 p.m. Same time, same place, same Facebook page. If you haven't liked and subscribed to the Arvin Gottlieb Planetarium's page, be sure to do that if you're watching on one of our other pages. For now, though, I have been Patrick Hess, your Planetarium Specialist. Thank you again for tuning in to another live stream, and thank you so much for continuing to support everything that we do at Union Station. We'll see you next time, everyone. Have a good week.